Thank you, Madam Chairman. I just want to say thank you to the presenters. Your expertise and dedication to this field is exemplary, and it's obvious. One person made a comment a few minutes ago, I think it was Mr. Murtaugh, about individual weather. That's what most people care about. They want to look outside and see if they can have a picnic or go to a ball game. But it's under your responsibility, it's under our responsibility, really, to look at the bigger global picture. And so I thank you for that. It's an important thing that doesn't have partisan politics in its back pocket. It doesn't have national politics in its back pocket, because the Earth is one place and it's affected globally by events that occur in the sun. So again, thank you for your dedication. It's really important, really, for us as a species, if it is. Just a couple questions. Now I'll be a lot more granular. I live down on the East Coast of North Carolina. My district probably has more coastline, than anybody else in North Carolina. So I want to crack your brains on seeing if you can help me. Is there anything that we have as far as space weather prediction? You know, we have these things called hurricanes, and we don't like them in North Carolina, but they tend to come right to us. And so I didn't know if there's anything that you guys have, up your sleeve that help us in the future to be able to predict the intensity, predict the path, predict the rainfall amounts that we can use to better gauge how these will affect us.
Yeah, and there's been a term we've been using at the Operations Center. We call it the money chart. And that's what you're looking for, is something that makes sense to people. But is it to identify when GPS may be having problems or when there's a potential grid problem? We are absolutely focusing, and I mentioned it already with the geoelectric field model, focusing on trying to capture that key piece. Where will the impacts be felt? We should be past that point where we're advising the whole world something's going to happen. It's going to hit somewhere, maybe in South Africa, maybe in Scandinavia, maybe in New York City. We have got to be able to identify and help the folks in North Carolina understand when space weather might affect them. So we are getting there. We have introduced a new suite of models, sun-to-earth modeling system, that's helping us just drill down and start. We're years away, but we have to start somewhere to get to that point where we can do just as you ask.
Excellent, thank you. Just one other question. You know, the United States, we seem to be leading in this regard. This is a global issue. It's a global phenomenon. How much funding does the United States put in compared to other nations, and where are we in trying to get our global partners to jump on the bandwagon and really participate this as an earthly event?
So we have very close partnerships with many of our overseas colleagues. We actually sort of work together on a lot of the missions. For example, Solar Orbiter, which is an ESA mission, has a couple of NASA instruments, but NASA is actually launching it for them. We are also talking to them about a possibility of an L5 mission. So Mr. Murtaugh mentioned the L1 point, which is 1 million miles away. L5 is kind of off to the side, so it lets you look at those sunspots coming round before they actually get to you. And so we're actually talking very closely with them about that. We talk to many of our sister agencies in other countries, because really, as you note, space weather is a global problem. It doesn't just hit one place. You may be unlucky, and we happen to be at the midnight sector, which is that kind of worst place to be as things come rushing down on the night side. But until we can really say it's going to be here at this time, and this is the country that's in that little window, it's really a global problem. So we work very, very, very closely with all of our sister agencies to really make this a global solution.
Excellent. Thank you, Mr. Chairman. I yield back my time.